Now let's discuss the difference of two squares. The difference of two squares is useful when you have a binomial that's a difference. So let me go through the idea. What we're trying to do is write this difference as a product. And the technique we're going to use is based on an earlier idea, and that is multiplying conjugates. Now recall that conjugates have the same numbers and the same letters, but one of the factors is a difference and the other is a sum. When we had conjugates and we multiplied, something interesting happened. Here, for instance, we'd get x squared, and then we'd get plus 3x, and then we'd get minus 3x. And this was the interesting piece. These will always be opposites when you have conjugates, and so their sum will be 0. And then the last thing we did was we multiplied here and got negative 9. I'm going to write negative 9 as negative 3 squared, and you'll see why in a moment. As we just discussed, when these two are added, we'll get a 0. And so this will simplify to just x squared minus 3 squared, which is x squared minus 9. Now to factor this binomial, we'll simply use this idea in reverse. We'll start with the difference. We'll be done when we've written it as a product. The way to do that is to recognize we have the difference of two perfect squares as long as we think of the 9 as 3 squared. This difference must have come from conjugates, and therefore the factored form will be x minus 3, x plus 3. That is the difference in the bases and the sum of the bases. So the idea will be to start here, recognize it as the difference of two squares, recognize that must have come from the product of conjugates, and that product will be the factors x minus 3, x plus 3. Again, if you choose to think of the factors the other way around, that's fine. So the basic idea for the difference of two squares is to realize that if we have a difference, there'll be a base squared, a second base squared, and the product will be the difference and the sum of those bases, and that these two factors can be in either order. Here's the first one for you to try. The point is to recognize this is the difference of two perfect squares, so we can use the product of the conjugates. In this case, here would be our two perfect squares. So our factored form will be the difference in the bases and the sum of the bases. That is k minus 6, k plus 6. How about this one? If we try to get this form so we can use conjugates, it would be the quantity 4y squared minus 5 squared. Notice this is the power of a product property. We would have two factors of 4y, which would give us 4 times 4 and y times y. Using the difference of two squares, this will be 4y minus 5 and 4y plus 5. And again, the order of the factors won't matter. Try this. Here our bases will be 3w and 7, and so here's our product. How about this one? With a problem like this, you have to recognize that 1 is 1 squared. So our two bases will be 5y and 1. And here's our product. Here's our last one. In this case, we have bases of 10k and 9, and that means our two factors will be 10k plus 9 and 10k minus 9. Well, that concludes this video on working with the difference of two squares.